We're going to be looking at lesson 3.4, linear equations and the intercept form. Our objectives are to be able to write a linear equation in intercept form, given a recursive rule, a graph, or a table, and also to identify the y-intercept and rate of change from an equation in intercept form. Some vocabulary I want to cover is, first thing is linear equation. We looked at those two different words separately, and I just wanted to talk about what they mean when they're put together like that, a linear equation. So an equation is something that has an equal sign. It's going to have two expressions on either side of an equal sign. And linear refers to something that is a straight line. So an equation is something that can be represented with a straight line graph. A linear equation has variables only raised to the power of 1. So I gave some examples below of things that are linear and things that are nonlinear. So again, something that is linear, a linear equation, is two expressions on either side of an equal sign. The variables in a linear equation are raised only to the power of 1. They cannot be raised any higher than that. Examples of graphs of linear equations are things like this, things that are straight lines. Something that's nonlinear has variables that are raised to powers higher than 1. And their graphs are going to look something like this, where they have curved lines. We're going to look at how to represent these equations in 3 different ways: algebraically, numerically, and graphically. So to represent an equation algebraically, we're going to write an equation, something that looks like this. To represent an equation numerically, we're going to use tables, and specifically what's called an input-output table. Input-output table. And then graphically, as you might guess, is we use a graph. We use the coordinate plane and we plot points from the equation. And you can see how those 3 different things relate to that first objective, where we're writing an equation given a rule, a recursive rule, or even a real-world situation, a graph, or a table. So we're going to talk about all this a little bit later, but first I want to start looking at our investigation. And we have a few goals in our investigation. We're going to be given a real-world situation, and from that situation, we're first going to write a recursive rule, then we're going to create a table, and from that table we're going to write an algebraic equation, and then we're going to take a look at the graph and how they all relate to each other.